Hi, this is Dale Rhoda, and the goal of this short video is to show you how to calculate vaccination coverage confidence intervals using Stata. As we indicated a few moments ago in the EpiInfo video, well, to have just a little bit of background here. When we calculate vaccination coverage, we calculate an indicator variable that's coded 0 for kids who are not vaccinated, 1 who are kids who are vaccinated, and missing, given a missing value for kids who are not eligible for the survey, who are not valid respondents for the survey. And when we calculate the point estimate, we don't need fancy software. It's just a simple weighted average. We've covered this in the earlier videos. It's a simple weighted average of this 0-1 indicator. But when we're going to calculate a confidence limits, confidence intervals, standard errors, we need to use software that takes into account the clustering and the stratification in the sampling design. We are going to need to assemble and know the names of 4 variables, usually at least, sometimes more, but always 4 at least. In order to do this work, we're going to need to know the name of the indicator variable we want to summarize, calculate coverage for, and then we need to know where are those post-stratified weights that we worked so hard to calculate, or the respondent weights. Maybe we didn't post-stratify, but what's the weight variable? What's the stratum ID variable? What's the cluster ID variable? Now in Stata, you load up your data set. So we assume that we've done that. This case, these examples are going to use the data set from your creator project for the course. And then you use the survey set command to tell Stata about the sampling design. So in this case, we tell it the name of the variable that holds the cluster ID, the primary sampling units. And then in the Strata option, we tell it the name of the variable that holds the stratum ID. And in this case, we're summarizing it using the one-stage syntax, and so we tell it the name of the weight variable using the weight option. In this case, this is the post-stratified weight. We just do this once, and then we can run a number of survey estimation commands. We don't have to do this before every command, but we do have to do it in every session, every analysis session where we're going to estimate survey quantities. And then the syntax for estimating coverage, in this case, we want to estimate crude BCG coverage by card in the state of Yobe. So we use this syntax, SVY colon, and then proportion, the name of the variable, this is the indicator variable, and here we're limiting it because we just want to calculate coverage in Yobe. So when we type this variable in, here's the table that results. The proportion of ones in the data set, the weighted proportion of ones here, is 0.047, and as is the case with EpiInfo, we would need to multiply this by 100. So the estimated coverage here is 4.7%. And the Logit 95% confidence interval, it goes from 2.1% up to 10.3%. So this is a simple calculation in one stratum of coverage. The default confidence interval here is a Logit interval. Well, we've been saying we want a Wilson interval. So just recently in Stata 15, in version 15, Stata added the ability to calculate a Wilson interval. Now, if you're using an earlier version of Stata, the Logit interval is fine. It's quite similar to the Wilson, and it's much better than the Wald. So it's fine. Earlier versions of Stata calculated the Logit, but you can see here on this slide, we've specified that we want a Wilson interval, and that's what we got here. The estimated proportion is the same. It doesn't have anything to do with what confidence interval we're using. And I'm going to go back to the earlier slide, and we'll see that this interval is quite similar, right? This is 2.1% up to 10.1%. And for the Logit, it was 2.1 up to 10.3. So very similar. Don't worry if you don't have Stata 15 or later, but do know that starting in version 15, we can calculate Wilson intervals for survey proportions. Now, what if you wanted to know the design effect? So if you want to do that, then after you calculate coverage, you enter this simple command, estat, and then a space and the word effects, and it will list the design effect. In fact, it lists it in 2 forms. Depending on what tradition you come from, you might report the DEFF or the DEFT. The DEFT is the square root of the DEFF. In our sample size calculation, we use DEFF. That's what I call design effect. So I recommend that we would report that. But some reports list the DEFT. That's fine as well because we can always convert back and forth between them. So just read other people's reports carefully to know what they are reporting and be real clear in what you're going to report. I recommend reporting the DEFF. Now, what if we wanted to calculate some one-sided 95% confidence bounds? Well, to calculate one-sided 95% bounds, we calculate a two-sided 90% interval. And so we add this option to the syntax here. The syntax is all the same up front here. We're going to do a Wilson interval, but we're going to do a 90% interval instead of 95. And so now this number is the 95% lower confidence bound, and this number is the upper bound. It goes from 2.4% is the lower bound, and 8.9% is the upper bound. And these are the limits or the bounds that we would use if we were classifying coverage, as we've talked about before, and we'll talk about again in a future video. Well, what if we wanted, instead of calculating it in one state, what if we wanted to calculate it in a handful of states at one time? Well, now we're going to add this syntax, this over syntax. This is another variable that holds state names, and this holds them, this mix5hh7 variable. It holds the state names as an integer with a value label, and that gives quite nice output. So I've switched from using level 3 name, which also holds the state names, but that holds them in a string. The survey proportion command, if you use the over option, it wants you to use a variable that's an integer. So here I'm saying, please calculate coverage in each state for each value of this variable here. So we get 3 screens worth of output. We're going to scroll down. We see here that what they're calling proportion 2 is going to be the proportion of the kids who were vaccinated. So we're going to look for the part of the output that's called prop 2. And these are the states for which it is calculated. We're going to scroll past this output down here to the output for prop 2. Here's what it looks like. We don't care about the prop 1 output. That's the proportion of kids that weren't vaccinated. Well, we're going to focus on the kids who were vaccinated. So that's prop 2. And I'm going to put those labels back here so we can see what we're looking at. So here are the state names. Here are the estimated proportions. Again, we would need to multiply them by 100. And here are the Wilson confidence intervals, the lower and upper limits of the confidence intervals. So that's how to get coverage estimates for a handful of stratum using a single command. I hope this has been helpful. If you have comments, please post them in the Scholar community update where you found the link to this video. And if that's not working for you, then send me an email. Send email to the course team listed here at the bottom of the slide. Thank you.